From South Bend, Indiana, welcome to 3Degrees Discussions. I'm your host, Mike Vasquez. This is a podcast devoted to the stories behind the innovators, entrepreneurs, and leaders in the 3D printing industry.
There's sort of a realization, I think, globally that resilience, that manufacturing is integral to what we might define broadly as sort of, population level health, national security, like these really big topics. And at the same time, manufacturing is integral to research, but not often the priority of the research. Like, we develop something in the lab that's interesting. How do you scale that technology, or build a robust hardware system that's affordable for whatever the application is, right, around that technology?
That's Haden Quinlan. Haden is a senior program manager for MIT's Center for Advanced Production Technologies. There, he's helping to steer MIT's efforts in additive manufacturing, workforce development, and industry collaboration. He's worked across the MIT innovation ecosystem, from supporting startups to driving partnerships that advance digital production. Before we get started, head over to www.3degreescompany.com and subscribe to the podcast. Remember, you can listen to the show anywhere you download your podcast, including Spotify, Apple, Amazon, or Stitcher. Also, if you or your company are looking for materials, qualification, or data management support, reach out to our team through our website or via email at info@3degreescompany.com.
Hayden, thanks so much for joining the show today. Excited to. It's been a while since we've reconnected, so I'm excited for hear some of the updates and all the cool stuff you guys are doing around MIT. And for those who don't know you, maybe just start with a little intro going all the way back. So, where are you from? Where were you born? Kind of, what were some of those? Do you have any early memories tying to engineering, manufacturing, AI, or anything like that when you were kind of just growing up that led you to where you are today?
Yeah, well, that's a long history. So I was born in Newburyport, Massachusetts, which is convenient when you get a job in Massachusetts and you need to get your birth certificate, and you can just drive up and grab that. And then moved to North Carolina, spent 10 years there, came back to Boston for college, and the rest is history. So joined MIT in, I think, the end of 2015 or 2016. Time flies, you forget. But I've been at MIT for about 10 years, always working in the additive space, in the Department of Mechanical Engineering to start, with Professor John Hart, the name folks might know, co-founder of Vulcan Forms, Desktop Metal, and a couple others.
Also a previous podcast guest.
Oh, okay, great. I haven't listened to the John podcast. I should listen.
Just telling us the most popular that we've ever had.
Is that true? Okay, well, for now,
yeah,
right?
Maybe that's right.
Will. As far as early, kind of what got me into manufacturing, it wasn't very early, actually. Like, my background is in Arabic, Mike. I thought I might work for like the CIA or something like that. Finished college in 2015 or so, and needed to get a job, and there was a position at MIT. I'd been temping there part-time, and I thought, MIT is a pretty nice name. There's some smart folks there. I'm sure I'll learn something cool, and use that as a springboard to then go and build this different vision of a career. At the same time, I was like getting interested in woodworking and hands-on projects. I hadn't done that as a kid. My dad is not a very handsy guy. Unless we count like mowing the lawn as artisan craft work. And I realized there was a lot I didn't know, but it was really exciting, right? Like, we interact with physical products every single day. Like, they are so entrenched in our environment. You know what I mean? That I think is the average person I used to be. I just thought stuff showed up. Like, the world is full of these physical things that someone just snapped their fingers and they came to life. And when you start popping the hood and you realize just how much work, thought, engineering effort, also like creativity, problem solving, and hand skill, like really, fine motor control in some cases goes into this, it sort of blew my mind a little bit. And I sort of got an appreciation for the fact that, in a way, I thought the most important thing in the world when I was younger was like politics. I thought it was like the governments and how money is allocated. Of course, that's still important, but often I think my recent realization, like in the last 5-10 years, is our quality of life, the way we live our lives, like what we're able to do as people is directly determined by what we can make and how much it costs and what it does. And that got me really excited to think that maybe the vision of myself and my career in the future, making some impact, there's a real opportunity to do that when you engage with manufacturing and component engineering and so on.
Did you know that that first job at MIT was going to be manufacturing related, or was it kind of, hey, you're going to go work in mechanical engineering and we'll see what happens?
So the temp job was somewhat Arabic related, and then
okay, got it.
It was the fellowship program for Saudi Arabian women, and then the first job with John, I didn't know it was going to be additive related. It came actually out of a consortium idea. So at one point, way back in the day, 2018, 2019, we had a consortium around additive. The pandemic sort of sidelined that. But I had led an academic consortium on Middle Eastern studies in college from a program's point of view. And so John, department head at MIT, McGee, sort of the guy behind the consortium, wanted to do something similar in the additive space and said, "We have experience. You have, done this before, right? Help me build this thing." And I just thought that was a cool opportunity. Again, back in the day, right? I don't know much about engineering, don't know much about manufacturing in general, but I said the opportunity to engage with leading companies and build something meaningful that's exciting to me, sort of independent of what it is we're talking about. And then I got very excited about what it was we were talking about as I learned more.
Thinking back to that, what were some of those conversations about what they were thinking about in terms of manufacturing additive? How did those compare to what you hear today?
Well, very big difference. So I think, you can kind of liken it to maybe what you hear with AI today, which is a lot of folks envision the future and are really focused on that exciting vision of the future, right? So a lot of the value propositions that you heard about additive, if we have a critical view and reflect back, some have been realized really strongly, right? Like design freedom, design flexibility, make products that perform better than conventional counterparts. I have some little tchotchkes here. I don't know if they'll show,
yeah.
But like spinal cages or other sort of implanted devices, right? Really compelling stuff. We heard that 10 years ago. We hear it still today. Other things that were maybe exciting is vision of fully distributed production infrastructure and true flexibility and supply chain resilience, which wasn't really that exciting until the pandemic, but generally that concept, I don't think you see a lot of that still to this day. Doesn't often make sense to build 20 different small facilities versus have 2 really capable ones. Same thing with bridge production. There are a few good examples. I think GM had a great example using HP's technology to get some SUVs out of the warehouse and into customers' hands. But generally, I don't think you hear a lot of bridge production use cases. Certainly, we talked about it 10 years ago, and then I spent 6 years looking for examples to put in our online course, and it took a while to find a really good one. At the same time, the past was really dominated by excitement, that vision of we're this close to the future. And, industry insiders who might be the bulk of people who listen to this podcast, right? Things are a little bit more depressing from the inside view these days. But at the same time, I don't think that's a bad thing. Additive is becoming a tool in a toolkit, and certain business models, don't exist for CNC machines or injection mold machines that people tried to make exist for additive. And they were really just ways for us to, part screening, part selection tools, for example, right? You don't need that for injection molding. Those don't exist. And we built those for additive because we were trying to make the technology work and realize that vision. So I'm kind of rambling, but the point I'm trying to make is I think it's become a much more normal technology in a way. We kind of know where it fits, know where it doesn't. In some cases, there might be too much skepticism. Folks got burned by immature technology that is maybe more mature than they might think. But so I don't know. I'm not very depressed. I'm actually fairly happy that additive is reaching this point of maturity where people know what it can do. They know how to audit marketing claims, and they can find real applications with value without spending a lot of money in the trial and error phase of figuring things out. And certainly your program helps, right?
Do you remember the first time you saw additive?
The first time I saw additive
in person?
I had a not bamboo, sorry, a different company that didn't exist that long ago. I had what was it, XYZ Da Vinci
Yeah.
Mini.
Yeah.
That was the first. Horrible software experience, and I printed a Yoda head. That was the first. And then I thought I would be really clever and print a chair in puzzle pieces. And I printed a few puzzle pieces, but not a chair. So that was maybe the first time just making fun tchotchkes, just figuring things out.
Yeah. And maybe talk a little bit about kind of MIT's approach to, I mean, there's additive with the course, and it'd be great to kind of hear your kind of updated view of that and kind of what's going on there. But just more generally of like from the press releases that we see and things, there seems to be a lot of activity around it. I mean, when I was there as a student, I was a materials engineer. Yeah, there was a manufacturing and materials course like every university. There was some stuff in the business school, but not so much. It was at the time there's like 2008, 2009 ish, like biotech, biomaterials. That was the big thing. Not so much like, okay, how do you make it? But it's really seemed to kind of the conversation about manufacturing and has seemed to kind of pick up a little bit more, at least from an outsider perspective. I'm not, like, other than I visit once a year or something like that, but that's just from my impression. But how is that on the ground being there every day?
Yeah, I mean, there's maybe two elements of that question: one additive and one manufacturing or advanced manufacturing more broadly. Just on the additive side, folks often reach out to me as one focal point in the additive ecosystem at MIT and say, "Who's doing X, Y, Z?" And when I go and search, I always find more names. And what's interesting, I think, some of the capabilities of additive, the ability to like tune things at the voxel scale, to not have to make significant investments in like tooling, or you can just generate a shape to do something somewhat quickly, right? Depending on the process and the complexity of the shape and so on. It's an extremely useful research tool, even in cases where additive is not important to the research. So sometimes it might just be the shape, right? It might be new alloy design and the ability to do, sort of in-process alloying or mix different powders, right, for mixed material compositions that may not be printed in the future. And so there's a ton of research like that where and just to clarify for the audience, we have a few additive centers, pretty broad range of machine tools, everything from, low-cost FDM to like large cement printers and things in between. So folks reach out to me and say, I want to accomplish X. Additive is often not important. It's whatever the X is, right? The actual shape. That said, there is still a lot of fundamental research happening at MIT. I think, you might get the impression if you read industry news that additive is not that exciting. Development has stalled. Totally not the case. Everything from basic process research, so studying like particle interactions and the cold spray process, for example, to building new machine architectures. In John's lab, for example, there's some interesting concepts there around combining different processes together to do in-process alloying or creating gradient materials. So really spans the full spectrum. I will say I think industry, the way we engage with industry has changed. There's a lot less speculative interest, like tell us about this additive thing. And we get a lot more grounded, very direct inquiries, right? Can you modify a material, and the corporate sponsor might have a vision for what that modification looks like. In the case of like cement 3D printing, for example, dosing the cement mix with fibers or other types of materials to increase properties. That's pretty typical. So we might get a request like that. Folks tend to know what they want because they now have experience with the technology, which I view as really nice. Because we get much better scoped projects. Expectations are much more aligned. Folks don't expect that additive will do everything, but they kind of have a good understanding of what it could do. And so we get pretty good results with that. On the manufacturing more broadly, so MIT recently, a few months ago, announced the Initiative for New Manufacturing, which is it's a presidential initiative, which if you're not at MIT might not mean anything to you, but at MIT that's very significant. Means that it is, sort of cross-cutting, university-wide program, and it's been in the works for a long time. So there was sort of this revelation that happened in 2020, especially with the pandemic, things that happened with supply chains there, and not just like supply chains for commodity goods, like the cost of container shipping and so on, but with medical products and other types of products where there's sort of a realization, I think, globally that resilience, that manufacturing is integral to what we might define broadly as sort of population level health, national security, like these really big topics. And at the same time, manufacturing is integral to research, but not often the priority of the research. Like we develop something in the lab that's interesting. How do you scale that technology, or build a robust hardware system that's affordable for whatever the application is, right, around that technology. And so given those two revelations, the number one, manufacturing is sort of always comes after a good lab exercise, and that manufacturing is becoming increasingly important to the globe, there's a big thrust at MIT to sort of centralize the efforts there and amplify the work that's being done across the institute. And if I ramble just a little bit more, I think one thing that's really personally like I'm passionate about is MIT has a really long lineage in manufacturing. So seminal inventions, like maybe folks don't know this, the CNC machine. Depending on who you ask, some people have strong opinions if you're like really deep in the history. So I will say it very carefully. But MIT helped to develop and commercialize the CNC machine, and where MIT's main, like the biggest, definitively MIT thing was in the programming language, which coincidentally was called APT, Automatically Programmed Tool, which is also the name of our research center. So just like a funny coincidence. And you can read these old president's reports, and you get so many parallels to the present day, but you're reading this report from like 1947 or something like that, 1948, 1950. And at the time, right, MIT leadership was thinking, if we want to train the next generation of engineers who can actually go and remember, this is the post-war period. So folks are very interested in how can we go from bright ideas to fielding products very, very quickly, right? We want, like, this is about doing more than it is about, the intellectual components of it. And the realization was, number one, that we need facilities, that we need programs, we need intentionally to get students out of, in that day it wasn't the computer, but today's day would be like CAD, right? Get them out of CAD and get them into the shop and have them connect the dots between those two, the way that their design decisions influence the manufacturability, the cost, whatever it is, the quality of the component that they're trying to design and the application that they're trying to design for. That was one thing that's very resonant today. And a lot of the investments that we've made in machine tools, or the way we've upgraded programs, has been around that, trying to get more hands-on, more sophisticated with the way that students engineer things, and build the interface between digital tools that they're typically working on and the physical tools that those digital, the digital infrastructure will kind of support or direct. In the case like robotics or a mill will drive. The second thing that was interesting about the CNC example is, well, it's a very MIT story. So the CNC machine was built to make one part. They didn't know how to make it. They said, can you build us a machine to make this one part? I forget what it was. And MIT said, sure, but we'll build you a machine that can make a lot of different parts. So I think that's just like the spirit of MIT. How can we stretch our imagination and kind of go for, the big vision? But the revelation, especially in the Air Force, I think this was an aircraft component, was that the tool is so transformative that MIT needed to build coursework to train industry to use it. And so I think the first example of professional training in MIT's history came out of the invention of the CNC machine to teach Air Force personnel how to build aircraft components using it. And, a lot of my work is in professional education for additive, so that sort of clicked and resonated with me. And then there's like there's a longer history after that, but I don't know if the audience wants a history lesson. I will just say, I don't know if folks know this, 3D printing was coined by an MIT professor, Ali Sachs, during the invention of binder jetting. So we also have a little flag to plant in additive, though of course not the first process technology that was you could ever call 3D printing.
So on that line, I think you mentioned a few different kind of threads on the kind of education, training, workforce side. So you get to interact with students taking the online course. There's students at MIT that you're kind of building this presidential ecosystem around, and there's obviously the companies that are coming to learn and things like that. There seems to be a much different perspective of what manufacturing is and the importance over the last 5 to 10 years, right? Like you come to someone with this idea of 10 years ago and they're going to be like, okay. Like, but either the realization after some of the COVID stuff or just some of the digital tools that are now available, like what's the perception now, right, of manufacturing? Is it interesting to students there? Is it to fulfill a need? Are people kind of clamoring to get into these different positions? There's a lot of talk about it, obviously, and a lot of movement, a lot of investment, but like on the ground from a learning perspective, where is the student kind of getting pulled in as well? Or are they kind of pushing the door down to get in?
So I'll break it out into kind of on-campus MIT students and professional students, because very different, sort of incentives there. When it comes to the MIT students, I will say we are never, I don't think ever going to beat computer science and AI, ML, because the paycheck you get when you graduate is so big. So, we're constantly...
No manufacturers giving out the $150 million a year.
We're a little jealous. I'll just say that. We're a little bit jealous. But there's absolutely more interest for sure. And actually one thing I found interesting, and I could find the study for you, study might be a stretch, the survey, the number one employer or types of employers for young graduates these days are like defense contractors, if you can believe it, like folks who do very complicated manufacturing, RTX, LMCO, and so on. If I remember the thing, and they beat out the FANG companies like Google and Apple and those. And I thought that was pretty interesting to see that, and I think it's validated a bit at MIT. And I'm just speculating here, if I can give you reasons why. One is that there's historically an impression that manufacturing is very boring and very, it's like the 3Ds, dull, dirty, dangerous. And when folks come and see, a very clean shop that is making very, very precise components for, MEMS devices or implanted like medical devices, and often the instruments we're using are tweezers in some cases, right? We're working in fume hoods. I mean, it's a totally different vision of what a factory looks like. And I think it's much more exciting. It feels very, sci-fi, like you're pushing the boundaries of what's possible. That's one piece.
Second, something comes out at the end, right? There's something physical, right?
For me personally, that's very motivating. Like I love work I can touch. And sometimes you spend like 3 weeks on PowerPoint slides or whatever, a proposal, and you're like, I didn't really do anything. I just typed on my computer. The integration of computation with physical processing is also something that's very exciting to folks. So I mentioned we don't beat comp sci, but sometimes we team up with them, especially on design, process optimization, even material science, like new material discovery. There's a lot of machine learning that goes into that. Depending on what material we're talking about. And I think that's another aspect that plays to manufacturing's benefit. Is just that folks can get really excited about those computational workflows that they see as the future, and to your point, then they get something out at the end. And then third is, I will say, like, I think students, especially MIT students, are very entrepreneurial, so they have a good sense of like reading the room as far as what technologies are driving sort of the next stage of industrial investment, sort of economic transformation. And surely, there's historically been a lot of resistance in the venture capital world, right, to spend a lot of money in what folks call hard tech or deep tech, hardware, complicated hardware solutions. I am sure macroeconomic conditions make investing difficult today, no matter what, but there's certainly, I think, a lot more excitement, right? You see, like, entities spooling up that are just pure play advanced manufacturing entities like Beehive Industries. There's the Reindustrialized conference. I mean, there's a lot of exciting momentum around manufacturing and sort of a sense that we are on the cusp of new tools that will transform what it looks like. And we had that sense 10 years ago with Industry 4.0, but I don't think that like percolated to the average person. So I guess the distinction I'm trying to make is I think the average person now gets a sense that manufacturing is exciting and will be, sort of revolutionized in the near term, and they want to be a part of that journey.
Awesome. And so a couple more questions. I mean, I guess looking forward, kind of school years starting in a few weeks, what are you excited about? Like, what are some of the initiatives you're specifically kind of looking forward to in the next 6 to 12 months?
There's a lot. I mean, so we recently had a lot of press around some bridge work that we've been doing using cold spray equipment to do spot repair on corroded steel bridges. That's been super exciting. We have really a great relationship with our local Department of Transportation. They're all in. And so we're looking at doing more projects, continuing to refine that process technology and see where that goes, because could go anywhere. But based on the numbers right now, it's really appealing from the DOT point of view. We're something like quarter of the cost and speed of what they're doing right now. More things to figure out to validate that, but surely there'll be more of that. We have a few more demonstrations planned, and one in Mass, and then one we're working on with the state of New York. Second, I'm doing a lot of cement printing. I'm using cement specifically. People call it concrete. We're not using concrete. You need aggregate. We don't have aggregate, but doing a lot of cement printing. And that's been fun for me because I'm interfacing with different groups than I normally work with. Normally I'm working with MECI. This has been civil engineering, architecture. There's a lot more design. But also the machines, like the way the material is formed and the way it flows through the machine is very, very different from an FDM extrusion printer, for example. And very dirty. So I've been having fun. If you're like a mason, you'd call it playing with the mud. So that's been great. Printing very interesting things. One thing that's tough for me is I never know what I can share because I don't want to, say something and then have it be a public disclosure. Someone wants a patent, but I'll say there's some exciting work around topology optimization there, printing, topology optimized structures. As well as projects that we're doing with others focused on printing in place around objects, so using the environment as part of the structural system. I don't think I can say more than that, but surely there'll be publications and more I can put on the website later. So that's been a lot of that's been a lot of fun, and we print with Autodesk, so our machine is at the Autodesk facility in Seaport. There was recently a 3dprint.com article about it with a guy named Adam, our partner in crime at Autodesk, and that's also been a really great collaboration to embed closely with one of the leading software companies in Additive and tap into their expertise as well.
Fantastic. So last question, more of a fun one. So what's, do you have a book recommendation or a podcast recommendation or some sort of interesting piece of either motivational or kind of story or learning kind of that you kind of come back to regularly, or something that you've read in the last 6 to 12 months that kind of has made an impact you'd like to share? So we do there's a 3Degrees discussions book list at the end of the year, and we try and share out kind of recommendations that people have given me over the previous 12 months. So anything you'd like to add to that list?
Yeah, I mean, just going back to the story of the scene, like there's a book called The Machine That Changed the World, talking about the seminal invention of like CNC programming and automated manufacturing tools. I mean, every complex or most complex metal components we deal with today we benefit from the invention of that machine. I think it really sets the stage for what am I trying to say here? Like our understanding of the Industrial Revolution. From a school point of view, you just kind of say, okay, there's this sort of linear arc, and I don't think you realize just how exponential things get when we start injecting data and start injecting precision into the process. And so that's, for me, I think that's a great read. As far as personally motivating, though, I'll give you a fun example, Mike, which you can choose to include or exclude. Maybe it doesn't make it to your reading list, but a few years ago listened to like this audiobook series on Genghis Khan, and it was totally historical fiction. I'm sure they made up half the stuff, or it's like apocryphal or whatever. But now anytime I have like difficulty in life, I just say, would Genghis Khan fold under the weight of this pressure? And generally the answer would be no. And I think it's silly, but it personally is motivating. I'm like,
Yeah.
I'm going to be the Genghis Khan of this PowerPoint slide deck. Let's
you go. I
So,
like it. I like it. Awesome. Great. Well, thank you so much for joining today. If people want to check out kind of more information on all the work that you're doing, where would you point them?
Yeah, best resource will be our main website. That's apt.mit.edu. It's for the research center. If you're interested in the manufacturing more broadly outside of the additive context, that would be the Initiative for New Manufacturing, equally three-letter acronym, inm.mit.edu.
Awesome. Thanks so much.
Thank you. It's great having me. Great being here. Thank you so
Perfect.
much.